This is the test on systems of equations, so we'll look at the different methods we've learned to solve them. So first of all, in number 1 through 4, we'll be solving by graphing. So I'll make sure the equations are in the right form, which actually the first two are. So we will just jump over and say C graph. So for number 1, we have y equals 2x and y equals 6 minus x, which can also be written as negative x plus 6. So we need to graph these. We always start graphing by using the y-intercept. Now that's the constant. Notice this has nothing added or subtracted. So that means the y-intercept is 0. So this one starts at the origin. The slope is 2, or 2 over 1. So I can go up 2 over 1, up 2 over 1, up 2 over 1. And I'll also do the opposite because I don't know exactly where they'll meet. Down 2 over 1, excuse me, down 2, left 1, down 2, left 1. So this is my first line. And then we have, here we have a y-intercept of positive 6. So on the y-axis, we plot a point at 6. And this slope is negative 1 over 1. So I go down 1 over 1, down 1 over 1. And already we find the spot where the two of these meet. Now this doesn't ask this, but if it did, this would be consistent because they do meet, and independent because they are two different lines. So it has one solution, and that solution is this ordered pair, which is 2, 4. Okay, number 2, the equations are also already in slope-intercept form, so I'll just start right here. Y equals x minus 3, y equals negative 2x plus 9. Okay, so this one has a y-intercept of negative 3, so I start on the y-axis at negative 3. My slope is 1, which I can use as 1 over 1. So I go up 1 over 1, up 1 over 1. I keep repeating that diagonal pattern you see. That's my first line, y equals x minus 3. For my second line, it'll be a little above our graph, but that's okay. The y-intercept is 9, so we'll put it about there. And the slope is negative 2, so I go down 1, 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So we see that is where the two of these meet. So there is one solution for this. This is consistent and independent, and they meet at the point 4, 1. Okay, so for 1 and 2, we just say C graph. Now for number 3, I think we have to rearrange the equations a little bit, so let's do that right here. So x minus y equals 4. We'll do that one first. We want to solve it for, we want to rewrite it so it's in slope-intercept form. So I'll subtract x from both sides. Gives me negative y equals negative x plus 4. But I can't let the y stay negative, so I'll divide every term, all three of them, by negative 1. So we get y equals a positive x minus 4. So that was my first equation. Now my second equation is x plus y equals 10. This will take a little less effort. All we have to do on this one is subtract the x over, and we have the equation in the form we need. Y equals negative x plus 10. Okay, so here's 3. So my graph, I'll have y equals x minus 4, y equals negative x plus 10. My first line has a y-intercept of negative 4, So on the y-axis, I mark -4. My slope is +1, so I treat that as 1 over 1. So I go up 1 over 1, keep repeating that, because I want to make sure I know exactly where this meets the other line. Okay, we'll have to be careful. This is a little bit off our graph. It's up at 10, so 9, 10. So this one's -1 over 1. So I go down 1 over 1, down 1 over 1, down 1 over 1, and I keep continuing until we hit the spot where the two of them meet. So this also has one solution. That solution is at 7, 3. Okay, last one of the graphing. Again, we'll have to do some work to get it into slope-intercept form. So we'll do that on this page. First equation is 2x plus 3y equals 4. So I need to subtract 2x from both sides. Gives me 3y equals -2x plus 4. Then we need to divide everything by 3. Gives me y equals -2/3 x. And 4/3 is 1.3 repeating. You can find that in your calculator. So that'll help us know where to graph that point. Now the second equation is 2x plus 3y equals -1. So this one I'll also need to subtract 2x from both sides. And then divide everything by 3. So we get y equals -2/3 x minus 1/3. And that's 0.3 repeating if you'd rather have the decimal form to help you graph it. Okay, so let me transfer these onto the graph. Y equals -2/3 x plus 1.3 repeating. Y equals -2/3 x minus 0.3 repeating. So if you look at these two lines right here, you should actually already be able to see what our answer is going to be. That's going to be no solution, because these two lines are not identical, but they do have the same slope. They both have a slope of -2/3. So these are going to be two parallel lines, and they will never touch, so there'll be no solution. Let's look at the graphs so we can get a picture of it. So that's 1.3 repeating, so we go about here for the y-intercept. Down 2, 1, 2, over 3, 1, 2, 3. Down 2, 1, 2, over 3, 1, 2, 3. So that'll give us a good enough picture of our graph. And then this one, the y-intercept is -0.3, so it's just below the origin, but it follows the same pattern of going down 2, over 3. Down 2, over 3. So you can see how they do end up being parallel lines that will never touch. So there is no solution on this one. No solution. Okay, so that completes the first way we learned, which was through graphing. So now let's switch gears. In 5 and 6, they tell us to do it by substitution. Okay, so in number 5, our two equations are y equals x plus 8 and 2x plus y equals -10. So with substitution, it's easiest to see if there's a variable that's already all the way by itself. And there is. The first equation already has y by itself. So it'd be easiest to go ahead and say that we can take x plus 8 and substitute it in for the y in the other equation. So we replace this y with x plus 8. And again, the benefit of this is now, instead of having two different variables, we have just one variable, it's just x's. 2x plus 1x is 3x. We can subtract 8 from both sides. And then divide both sides by 3, and we get that x is equal to negative 6. So we have half the answer. We know the x value for the solution. Now we can plug negative 6 in either of the two original equations. I'm going to choose to plug it in the original. So negative 6 plus 8 is 2. So when x is equal to negative 6, y is equal to 2, and that is our solution to this system of equations. Okay, we'll follow the same pattern on number 6. X equals negative 4y minus 3, and 3x minus 2y is equal to 5. So again, the simplest thing is to see if there's a variable already by itself, and there is. That x is already by itself. So I can choose to take the negative 4y minus 3 and substitute it in for the x in the other equation. So just like x is being multiplied by 3, I've got to multiply this whole thing by 3 as well. So this one will take a little bit more work than number 5. 3 times negative 4 is negative 12. 3 times negative 3 is negative 9. And I can combine these like terms. Negative 12y minus 2y is negative 14y. Then I can add 9 to both sides and get negative 14y equals 14. And then divide both sides by negative 14 and get y equals negative 1. So I have half of my answer. I now know what y is equal to. And what I would prefer to do is plug it back in this version of the original, or this equation that was in the original. So I do x equals negative 4. I replace the y with negative 1. So negative 4 times negative 1 is positive 4. And 4 minus 3 is 1. So our x value is positive 1. Our y value is negative 1. Okay, let's switch gears now. The next one will be on elimination. So we're jumping to number 10. X plus y equals 13, and x minus y equals 5. So remember, with elimination, we want to eliminate one of the variables in the equation, either by adding or subtracting. Give me 1 second. I apologize, I got a bit of a runny nose. Need to handle that. Okay? Super professional. You know me. So on this one, we actually have a choice. We could either subtract the second equation from this one, and that would eliminate the x's, because that's 1x minus 1x. Or we could add the two equations. 1 plus negative 1 is 0. You can truly do either one to get the correct answer. I'm going to choose to add, because that's usually easier. So I have 1x plus 1x, which is 2x. I have 1y plus negative 1y, which is 0. So those have gotten eliminated. 13 plus 5 is 18. So by adding these two equations together, I've now eliminated the y, and I can solve for x just by dividing both sides by 2. So I get x equals 9. So I can plug 9 in for either of these two x's to solve for y. I'll just do it in the top one. So 9 plus y equals 13. Subtract 9 from both sides, and I get y equals 4. So my final answer is the ordered pair 9, 4. Okay, number 11. 3x plus 7y equals 2. 3x minus 4y equals 13. So here it's less of a choice because the 7 and the 4 that are in front of the y's aren't the same. So we can't just add or subtract to make that work. But the x's do both have a 3 in front of them. Now when they have the same signs, we subtract. So we've got to make sure we subtract every term. So 3x minus 3x is 0, so they cancel out. 7 minus a negative 4 is the same as 7 plus 4, which gives us 11y. 2 minus 13 gives us negative 11. So we can now solve for y by dividing both sides by 11 and getting y equals negative 1. You can plug this back into either of the original equations to solve for x. Just for a variety, I'll plug it in the second one. So negative 4 times negative 1 is positive 4. I can subtract 4 from both sides. Get 3x equals 9. And divide both sides by 3. Get x equals 3. So my ordered pair is 3, negative 1. Number 12. X plus y equals 8. And x minus 3y equals negative 4. So same with this one as number 11. It's already predetermined which one would be best to eliminate. The x's both have the same coefficient, which is 1, and they both have the same sign, so we'll subtract the second equation from the first equation. 1x minus 1x is 0. Those are eliminated. Y minus negative 3y is positive 4y. Because minus a negative is the same as plus a positive. 8 minus negative 4, same as 8 plus 4, which is 12. So then I divide both sides by 4. I get y equals 3. Okay, I'm going to choose to put the 3 back in the first equation, the one on top. X plus 3 equals 8. Subtract 3 from both sides, and I get x equals 5. So my ordered pair is 5, 3. That would be the point where these two lines connect. That's the point that works and is true in both of those equations. (13) 2x plus 6y equals 18. And 3x plus 2y equals 13. Okay, this one is different from the first three because none of the coefficients match. We have a 2 and a 3 in front of the x. We have a 6 and a 2 in front of the y. So here, you got to decide which ones do you want to force to match so that you can eliminate one. Now, I personally would choose the y's because I see that 6 is 3 times 2. So this is 3 times bigger than 2. So if I triple everything in this row, then I will be able to eliminate it. So 3 times 3x is 9x. 3 times 2y is 6y. And 3 times 13 is 39. So just for ease, I'm just going to rewrite this equation right down here. 2x plus 6y equals 18. Now I'll need to subtract this whole equation from the other because they have the same signs, and when they have the same signs, we subtract. 9x minus 2x is 7x. 6y minus 6y is 0. 39 minus 18 is 21. So I divide by 7 and find the x value is 3. Then I can plug this into any of these three. I can plug it in the original two. I can even plug it in this one if you want to, because this is just a rewritten form, a revised form of this one. I'm just going to plug it in on top. 2 times 3 plus 6y equals 18. 2 times 3 is 6. We can subtract 6 from both sides. We get 6y equals 12. Then we divide both sides by 6. We get y equals 2. So our ordered pair is the point 3, 2. That is where these two lines would meet. This is the point where both of these lines would be true at 3, 2. Okay, last set, 15 through 18. Here they're going to tell us we can pick which method we think is easiest. Now, if you want to graph them, feel free. I'm probably going to just choose between substitution or elimination. But on this one, you really can choose which one you think. There are ones that are easier than others, but you are allowed to choose the method you want to use for this. So as I look at this one, I think substitution would be easiest because y is already by itself. They're not both in standard form, which is most often what we do, the form we see when we're doing elimination. So I'm going to use substitution. Since I already have y by itself, I know I can plug this 3x in for this y. So 2 times 3x is 6x. 1x plus 6x is 7x. We divide both sides by 7, and we get x equals 3. So then I would plug 3 back in the original up here, and I get y equals 3 times 3, which means y equals 9. So my final answer is the ordered pair 3, 9. And just a quick reminder, you always put the x value first and the y value second. There may be times where when you're solving this, the y will be the first one you find, and the x will be second. But in the ordered pair, you'll always put the x value first and the y second. Okay, 16. X plus y equals 12. And y equals x minus 4. Same here as we did in 15. I think since this is already solved for y, it'd be easiest to do substitution because I can use x minus 4 and substitute that in for the y in that equation. So x plus x is 2x, and I can add 4 to both sides to make that equal to 16. Divide both sides by 2, and I get x is equal to 8. Okay, so I'll plug 8. I'll just plug it in this one. We get y equals 8 minus 4. 8 minus 4 is 4. So the ordered pair that is the solution to this system of equations is 8, 4. Okay, 17. X plus y equals 15. And x minus y equals 9. So since these are both written in standard form, I think elimination is the easiest way to handle it. And this one, like back on, I think it was 11, you can actually pick which one you want to eliminate. You could subtract the two equations, and that would eliminate the x because they have the same sign. Or you could add the two equations, since the y's have different signs, that would eliminate them. I'm going to choose to add them. X plus x is 2x. 1y plus negative 1y is 0, so they cancel. 15 plus 9 is 24. So then I divide both sides by 2. I get x equals 12. To find y, I'm going to plug 12 back in the top equation. 12 plus y equals 15. Subtract 12 from both sides, and I get y equals 3. So my ordered pair would be 12, 3. Last one, 18. 3x plus 5y equals 7. 2x minus 3y equals 11. So again, since these are both in standard form, I think elimination is probably the easiest way to handle this. But unlike what we did back on, I think, 13, where we just had to multiply one equation to fix the problem, we'll have to multiply both equations this time. So you have two choices. We can either multiply to make the 2 and the 3 both equal 6, because we want to look at the least common multiple. The smallest number that both 2 and 3 go into evenly is 6. Or you could multiply so that these two both become 15, because the smallest number 3 and 5 go into is 15. You can truly do either one. I'm going to choose this one just because they're a little bit smaller, but it's okay either way. So I'm going to multiply this entire equation by 2. 2 times 3x is 6x. 2 times 5y is 10y. 2 times 7 is 14. Now with this equation, I'm going to multiply everything by 3. 3 times 2x is 6x. 3 times 3y is 9y. And that's 11, right? Yeah, 3 times 11 is 33. So now that I've multiplied the top equation by 2 and the second equation by 3, the coefficients in front of the x's now match. Since they have the same sign, I'll subtract them to eliminate them. So 6x minus 6x is 0. 10y minus a negative 9y is positive 19y. 14 minus 13 is negative 19. Then we divide both sides by 19, and we get y equals negative 1. Now you can plug negative 1 into any of these four equations. It's fine to use the ones that have been changed to solve for x. It's truly up to you. I'm going to pick this second one. I get 2x minus 3 times negative 1 equals 11. Negative 3 times negative 1 is positive 3. Subtract 3 from both sides. I get 2x equals 8. Divide by 2 and get x equals 4. So my final answer for the solution to this system of equations is 4, negative 1.